Okay. Well, thank you for joining. I'm just going to go over a few things that we can expect, and how the final exam will be run. And then I'll answer any questions and just go over a couple things that I think might be important, things to remember, that kind of thing. So we will be taking the exam at our given time as if we were in person, because everyone should be free that time technically. And they really want us to try to do that if we can. So that's what I'm going to do. Our exam is 3.5 hours long, which is like extremely long, but it's not designed. Like I have not designed the final exam for 3.5 hours. And even if we took it in class, I do not design it for 3.5 hours. It's designed more like a regular exam. It's just you have that full time. So just so you know, you should have plenty of time to complete the exam. The multiple choice, everything's going to be set up the same, right? So the multiple choice is part one, no calculators, no cheat sheets, no mini tab, just yourself. And with that, I normally have on a regular exam 15 questions. This one will be about 20 questions. I may change that a little bit, but that's why I say plus or minus 20 questions. And that will be 20% of the final exam grade. For that, it's just set up very similar. So if you can review, I could probably open up old reviews, but you have a review on there. It's very similar to what you're used to. So there's really not a big change, which I think is a good thing for us. Part two, I have plus or minus 5 long answer questions. So it will probably be more like exam 2 than it was exam 1, meaning exam 1 was longer. I asked for like straight hypothesis tests, where exam 2 I had more follow-up questions. I even incorporated some multiple choice type things in part 2. I will probably do it that way. I don't want you guys to feel rushed. I don't want you guys to feel stressed about the exam. So I'm trying to like lighten it up a little bit. So I'm hoping to accomplish that. I have not made the exam yet, to be honest. So I have to work on that this week. Regression will be on the exam, right? We haven't had an exam with regression yet, so we know that will be on there. So make sure we can do the regression stuff for sure. And then it's going to be a mix of the other stuff too. But we know regression will be on there. If you look on I've got 2 computers, that's why I keep looking to the left here, because I have the other one pulled up on here. When you pull up the day 28 review folder, I have all this information about like the questions, and then I have information about how to start your problem. And that is by asking yourself, are you looking at proportions or are you looking at means? Do you have numerical data or categorical data? And that is the first thing you need to ask yourself before you can move forward with the question. Then you move on to how many samples do I have and that sort of thing, and maybe how many levels or how many variables am I studying, that sort of thing, within each one. So I have that written out. And then of course I have the flow chart, which I think is really helpful for us in the files. I think it's the last 2 files. I have the flow chart, and it has like the 2 different types of data and then how to tell and what day we worked on those things. So I think that's helpful to go back and study. And then I have a regression flow chart. And the reason why I do that separate, because it doesn't fall under, like the numerical or categorical data, then you have the 2 different types, the simple linear regression, then the multiple linear regression. So I kind of do it like a side by side. A lot of it's the same, and then a few things change when you go to the multiple linear regression. Okay. The exam will be similar to exam 2 in the way that I will give you the Minitab output. I have to do this. I have some students that cannot get Minitab. I have to do it so everyone has the same advantage. So I will be providing the Minitab. You are welcome to use Minitab though. So if I provide the data and you want to do something else, like get to know the data step, you know, I don't ask those, but if you want to do something like that, so you know what's going on, if you are free to use that. It's just, I will provide all the output that you need on the exam. So that will reduce a little stress as well, since that part's done for you. And I feel like it gives away a lot too. So that's also why I'm changing the exam. So it's more like, do you understand what's going on with the data? And not just the hypothesis test, but like, what does it mean? What's our outcome, right? What can we tell from that? All right. So on the review, you can see here, I have a review of all the long answer questions, like a whole bunch of hypothesis tests and CIs. Then if you go into the quizzing tool, you will see the review for the multiple choice portion. I can go over either one. I was just going to go through the part 2, the handout here, and maybe talk about how to identify what type of problem it is, because I think that's the hardest part. So it's hard because we started out with categorical data only. So we knew we were only in categorical data, and in our problem with exam 1 was we had to see how many samples we had and how many variables and that sort of thing. And then exam 2, it was all numerical data. And that was just, we always have one variable, numerical, we just have to figure out how many samples. Now with the final, you have that extra step of having to tell if it's numerical or categorical. I feel like by this point in Stat 2, we're kind of good at that, at least. We can look to see, oh, well, this is numbers we're studying, or this is a yes-no question, or a category someone fits into, if it's more than just 2 levels. So hopefully, you know, we could practice that, but I'll go through that. Each testing process has its own like steps that are required, right? Most of them in the beginning, we just incorporate our requirements right into the testing process. And then when we get into like the 2-way or 2-factor ANOVA, we drop it because we just cut the process down, right? So you're going to still follow all the same steps. Remember, numerical, when you're looking for requirements, you're checking for outliers and normality, right? And then for categorical, we're checking for that normality, right? So, you know, just keep that in mind, and hopefully that helps make some sense. So I'm going to look at the review. I have a hard copy in front of me, but then I remembered I changed it and I added some problems and I added a few things. So when I did the review solutions that you could see posted, I tried to have like the first piece of information before I started the test explaining like what type of data and, you know, how many samples, and so what that means to us for what type of test, because if I can't identify that, then there's no way I can move forward with a test, right? I mean, I can, but I don't know what test I'm doing, so that makes it really difficult. So like in number 1, we're looking at to test the effect of physical fitness. This is like the one I did, actually I did this example in class. It was really similar. Actually, it was like the same example in class that I did, where I said we're looking at how many sit-ups we can do at the beginning of like a fitness class. And then I want to know how many sit-ups the same people can do after the fitness class was done. This is my paired T. So remember, for a paired T, I have a few things. I have to have the same size N. So paired doesn't mean it has to be the same individual, but it can be. In this case, it is. So that's my clue that it's paired. And my N has to be the same. So if I have 10 people in the before group, I have to have 10 people in the after group because they link 1-to-1. So if I have 10 people in the before group and then 12 people in the after group, then I know it's not paired right off the bat. So that's my first key. When you're studying the same person before and after something, you know it's paired because there's something linking them. It's themselves, right? When you're looking for paired, you're just looking for that extra link. It can be 2 different people. So I might be studying the number of sit-ups people can do, and I might say, well, I took a group of people before and a group of people after, might have the same size N, but there might just be a group of people, right? It might not have anything linking the person in the before to the person after. That's when it's independent and it's just a choose sample. So you have to look for something linking them, like this is the same person. It can be someone with the same birthday, someone with the same age, someone that went to the same school, right? Something that's linking person 1 in the before group to person 1 in the after group. That's how I know it's paired. It can be tricky sometimes. I think that's like the hardest thing in the numerical data set to see that. Okay, so in question 1, we're looking at a paired T. Now remember, the order of subtraction matters in these. So when we're looking at something like this where we're doing the subtraction, I tell you it doesn't matter. It's just as long as you identify it. So like your middle steps might be different, but your end result would be the same as mine. And that's why on this first one, you can see I have it 2 different ways. If you subtract before minus after, or after minus before. So I just wanted to show you that it doesn't matter. You don't have to do it the same way I would choose. It's just as long as you pick a way, you follow through, and your answer will match. Okay. Remember, when we're looking at paired T, it's mu D. So mu D is the mean of the differences, right? So you're taking the differences, you're actually subtracting them first. You're getting a new column, subtracting them, and you're going to take the average of those differences. It gives you a better result than the 2 sample T. The 2 sample T is the opposite, where you're taking the averages and then you're taking the difference of those averages. So the notation is different. It's mu D here. And when I check my requirements, it's my column of the differences. So it's mu D. I'm looking for normality, and mu D, I'm looking for no outliers. Okay. If it was a 2 sample, I would take sample 1 and look for normality and for no outliers, and then separately take sample 2 and look for the no outliers and look for normality. Okay, so that's the difference in those 2 tests there. Okay, and you can see in here the notation. And then of course the interpretations change because I look for the order of your mean and differences. So mu D means mean of the differences. So that's how you should write your interpretation. So like for the CI on this one, it says the population mean difference. Okay, that's what we're studying. That tells me that you're looking at a paired T. If you wrote difference of the means, that tells me you're looking at a 2 sample T. So that's why I said in class before that the order of those 2 words matters to me, because it's telling me what you're doing. All right. So when I grade something like this and I'm doing like a CI and I grade the CI, I look for that order of differences would be like 1 point. Okay. Just so you are aware. Remember, when we're looking at like a 2 sample mean problem like this, for a CI, we always want to make that follow-up statement, and the follow-up statement's about 0 being in the CI or not. So if I subtract 2 numbers and they equal 0, that means that those numbers are the same, right? So that means that there's no difference between the 2 means. So if 0 is in the CI, I am showing no difference between the 2 groups. And that's the same interpretation if it's a paired or an independent, like a 2T. So 2 sample T. So I just want you to be aware of that, that we're going to do our normal CI interpretation plus the follow-up about 0 being in the CI. And then with the order of subtraction, you can tell which one's larger or which one's smaller, which group, right? Because if I take group 1 minus group 2, and when I subtract them and I get a negative number, that means group 2 was larger than group 1. Or if it's all positive, that means group 1 was larger. So we just need to be able to understand that and to make sure that makes sense to us from the output. So you can see here, like I gave you in the solutions, like the output, and I could just write my entire write-up from the output. The only thing, oh, it's right here. I was going to say the only thing is if it doesn't tell me which order I'm subtracting, but it tells me at the bottom, it says before minus after. And that right there is telling me how, you know, which one is larger. Any questions on like a pair T or 2 sample T, since we're talking about those at all? Okay. You don't have to ask questions. You could always think about them and ask, email me, or we could do a Zoom chat later on. So that kind of addressed a lot with paired versus 2 sample. Number 2 is just a 1 sample T. It's just saying we're studying miles per gallon, and it just gave you a whole bunch of data, and we're just going to go back to a 1 sample t-test. That's like what we did in stat 1. So it's really not, this kind of a test shouldn't be a big deal for us, because it's like we've been doing this one the longest, right? So I really don't have much to say. There's no follow-up statements on this one. It's just a conclusion, because there's just 1 sample. I'm not comparing 2 things here. All right, and number 3, I have the 1 proportion test, so same idea as number 2. It's something we've been doing for a long time now. Again, no follow-up on there. I'm just checking our regular requirements, nothing different. I don't think there should be too many questions, but if there are, feel free to interrupt and ask. Okay, then when I look at number 4, I can see that I have days of the week and absences, and I want to know if they're equal frequency. Right there is when I'm looking to see it's a chi-square test, goodness of fit. Like, I want to know, is it equal across, right? Or it might say, like 25% on Monday and then 10% Tuesday or something. So we could fit it to that specific breakdown. So remember, goodness of fit has the 2 different breakdowns, where it could be a given breakdown, or it could be equal across all things. So here it says equal across all 5 days. So we want to know, are they all 20%? This is like one of the longest write-ups, because I have to define all of these. P1, P2, P3, P4. But if you remember when we did this, which was a long time ago, because this was like one of the first new tests we did, you're just defining, like, this is like the population proportion of absences that are on Monday. And then the next one, P2, is the same thing, but for Tuesday. So you could just copy and paste it and just fill in the last part. So that kind of helps. And then in here, my method is P1 equals P2 equals P3 all the way through P5 equals 1 divided by 5, or just 20%, you can say. My HA on these is just something is different. We've done that now for a while. If we have multiple samples or multiple levels, then it's just 1 is different, right? At least 1's different, and it's causing me to reject my null, that they're all the same. So we see that a lot actually now. Okay. Remember, our requirement here is that all expected values have to be 1, and we can't have 20% of them, of the cells, to be less than 5. So that's the calculation. The expected here is just 20. So they're all greater than 1, all greater than 5. I'm good with my requirements. If I had 1 that was less than 5, it would be okay, because that would be 20%. But I couldn't have 2 cells. Okay, and that's in my expected counts column. And again, we could just get that right from the output. I don't have to do anything different with that. I can just see it right from the output. All right. Let's see. Number 5, we're getting into an ANOVA. So here is a lot of times when you just look at the data given, like if you have a table, you can get an idea of what's going on. Here we want to know how productive U.S. workers are. And we have a random sample of companies in the different types of companies, like in computers and aerospace. So we've got 4 different ones. So that's telling me I have multiple samples going on, it seems like, right? It seems like I have like samples from different things. But then I'm going to keep reading, and I'm going to look and say, okay, Well, I want to know if that type has an effect on how productive, how many hours, I believe it is. So, and then it says, is there a difference in the population mean annual, profits, sorry. Okay, so it's profits per employee in each of the 4 companies. Okay, so right there we want to know, so the company play an effect on the profits, right? And that's going to be my goal. So here it's just a one-way ANOVA, right? I don't have like 2 factors. The one factor that I'm looking at is the company, and the response variable is the profits. Okay. So I feel like this is probably a little bit fresher in our mind because we did this right before. Did we do this right before break? I can't even remember now. Everything is like all blurred, like when we did what. So this was more recent anyways. All right, number 6 is a 2 sample T. I believe it looks like group 1 is longer, but I think when I typed it in, it was only like 1 longer. It was, because I have 29 students. So it's one group has 14, the other group has 15. Right there, when I have that, that tells me that my ends are different and it's not a paired T right off the bat. I don't even have to read about the problem. I can just tell that from the data. But if I didn't pick up on that, then I would look and just say, well, if there's a group, well, it does say 15 right there, but there's a group 1, and then there's a second group, and it just says 14 people. It doesn't say anything about anything linking the person 1 to person 1 in group 2. So that should make you think it's a 2 sample T, which we've already discussed the differences between the 2 sample and paired T. You know, and like with checking the requirements and everything. So you can even see how I check my requirements in here. I'll just say the NPP's values for both are greater than 0.05. Like I just group it. If they have the same outcome for my requirements, I just make one statement. I don't go overboard. I mean, you can make 2 separate statements about each group, but you don't need to, just so you know. Okay. And again, with my CI, I'm going to make a statement about 0 being in the CI or not, and what that means to me. All right, and then 7 is 2 proportions, so the same idea as the 2 sample, and I feel like that one's a little bit easier for us. So with the 2 sample, I'm going to check normality on both individual you know, groups, samples. I'm going to define each sample, each group, that kind of thing. Okay. All right, number 8. This one I want to know. Let me read it here. So I can see a table and I've got a lot going on, so I have to see what I have. I know it's not a 1 proportion or 2 proportion here. So I want to know if the registered voters and their opinion. So what does the sample show about the voters' opinions concerning the proposal? So I've got type of here, typed twice for some reason. Let me see if I can remove that. Okay, so I have type of resident, and then I have if they favor or oppose the governor's proposal. So here I can tell it's categorical because they fit in a category. Do they favor or oppose? I know there's numbers representing it in the table, but it's just the counts. So don't get counts confused with numerical data because I have to show counts, right? So I could show it as a percentage. So here, just think, okay, I have either for the urban residents, they either favor or they oppose, right? And then same, you know, with the other 2. So they fit in those categories. So it's categorical. Now I want to look at what I have going on. So do I have 2 variables or do I have multiple samples? So I'm going to go back up to my problem and try to figure this out, because when I'm looking at something like this, it's categorical, and I know it's not 1 sample or 2 sample, then it's either going to be association, or it's going to be homogeneity. So I have a visitor here. So when I look back at question 8, it says each person in a random sample. So right there, Ryan says hi to you. So right there, you can see it says a random sample of 5. Oh, he says hi. When you see a random sample, that means it's a single sample, okay? And that means it's association. Remember, association and homogeneity, it could be the same problem, but just the way it's worded. Homogeneity means I have multiple samples. So it would say that I took a sample of urban residents, a separate sample of suburb residents, and a separate sample of rural residents, right? And I would have 3 samples, and then I want to look at the favor versus oppose. That's not what I have. Here I have a sample of 500, and I've asked 2 questions, okay? So I just want you to think about that when you have that. The 2 variables are, do they favor or oppose? So that's one, and then the other one is the type of residence. So that makes it my association. This is the trickiest one so I think seeing if it's paired or independent for numerical is tricky. I think this is the tricky part about categorical. Is it going to be homogeneity or association? Because it could be the same problem. It's just the difference in the wording if it says a random sample or if I took 3 random samples. Okay, so that's the key. That's the thing to look for in that. I don't think the testing process is hard, and I think you guys understand, like you could have your cheat sheet and you can fill out the different testing processes and have ideas of what to do, but if you can't tell what type of test, that's where the problem comes in. So, and that you can't really put on your cheat sheet. I mean, you can put the flow chart, right? But that's practice, okay, how to tell what type of test it is. So I think we're probably good unless there's questions on the actual testing process. Again, it's still chi-square, so I still have the same requirements as I did in the previous question, where I want to look for the expected values. Some of my output on this review sheet's old. I didn't update some of the output, but it looks fairly similar to what we see now. Okay. All right. So let's see. Number 9, we have a 2-factor ANOVA. I feel like the ANOVAs are the easiest ones to pick out for the numerical, because I don't know, I just feel like it's like, I don't know, it just kind of falls into place. So here we're looking at testing the significance of the effect of gender and age group on the number of hours a person watches TV. So right there, my factors are gender, and then age group is the other factor. And I want in my numerical or response variable, which is my numerical variable, is the number of hours a person spends watching TV in a week. So right there, I have 2 factors. The only tricky part about this is if it's 2 factors or 1 factor with a block, because it could be this very similar, but remember I tell you exactly what it is. I will tell you if it's a block, right? I'm not going to try to trick you with that, because that's not what it's all about. So I will tell you, like I did on exam 2, if it's a blocking variable, just make sure you include it in your testing process that it's a block. What's nice about the 2-factor is the testing process is super short. It's just we have 3 tests within the 1 testing process. So the first test is for an interaction, because remember, when I'm looking at my output and when I'm building my mini tab, which I will do this for you, you have to put gender and age group in, and then the cross between them. So the multiplication, gender times age group. My very first test in my 2-factor ANOVA is my test for significant interaction. And this is where I'm just going to look at that one line and I just do like 5 parts, right? It's a really quick test. My null, my alternative, my p-value, and I can report my f-test statistic and then my conclusion. So here it's just, okay, it's a 0.234. So I don't have evidence of an interaction, which is a good thing. That means I can move on to my main effect. Then my main effects are equally short, so they're just the 5 steps where it's the null, alternative, my f and p value, and then my conclusion. And with these, I'm going to just look at the line that corresponds to age group and gender individually. Now what's makes this one a little bit longer is that I have a follow-up, and that's that Tukey's, right? So Tukey's isn't tricky, but I don't know, maybe if it's tricky now that we're online. I don't know. Because if someone has missed this class in the past, then I've noticed that they've had a hard time with it because they're not hearing it. So the Tukey's, I'm just looking to see what is different. So if I'm looking at my test above for age group and gender, both of my p-values are less than 0.05. So I am saying that age group has an effect and that gender plays an effect, you know, has an effect on the number of hours. So then I want to know, that's just telling me something's different. So I want to know what is different. That's all it is. Of course, if I only have 2 levels, like if it's just male and female for gender, then I just know they're different from each other. I don't have to move on to Tukey's. I don't have to do anything. I can just say that they're different from each other because there's only 2 levels. But if I have like 3 or 4 levels or more, then I need to see what is different, because it might be 1, it might be 2, and that's where you're going to study either the p-value, right, or the CI. I think the CI is really simple because we do that a lot, where we want to know if there's a 0 in the CI. The 0 means there's no difference, right? So that's kind of like an old, like something that we've looked at a lot in the past. All right. So my Tukey's, I just want to make a conclusion statement about that. All right. Number 10, this one really does not give you a lot of information. It just says our goal is to predict home selling price using predictors, area, acres, rooms, and baths. And then I give you this output. I don't know if I gave you the output, but I have the output here. So when I'm doing this, I know it's regression, right? Regression is when I'm predicting a y based on some x. It's just now I don't have 1x, I have 4. If I have 4x, that means I have 4 predictors, and that means I have multiple linear regression, right? Simple linear regression is when I have 1x and 1y. Multiples, multiple x, 1y. You only have 1y all the time. Okay? So we have multiple ways of doing this. We kind of started out easy, and then we just worked our way with multiple linear regression. So depending on what the problem asks, you may be asked to build like a bigger model with some of those interaction terms, and then maybe scale it down so it's a great model where it only has significant terms. You might be just say, okay, let's just build a multiple linear regression model like we did in the beginning. So we have a lot of stuff going on. So our output always looks the same though, based on what I have in my model. Remember, if it just says to build the model, I'm looking for the equation. That's what we're looking for. Although we get all this output, which helps moving forward. Here I've got my model utility. That just means that my slope or my coefficient is not 0. That's my HA, right? So that's the same for simple linear regression or multiple linear regression. Again, I've got some short test processes in here. And I can look to see if each individual is significant by looking at each p-value. Okay, we look for less than 0.05. If we're building a better model, then that means I'm looking for my p-value to be less than 0.15. Like we just lighten up, we like loosen up a little bit on that p-value, because 0.05 is pretty strict. All right, and that goes through this whole thing. Now, I can't ask you to do backwards elimination, right? Because I'm not requiring you to use Minitab. So I may, I don't know, because I haven't done it yet, I could do something where I build a big model and then I scale it down myself and maybe ask you questions on the Minitab output and understand what happened, right? So that could be a possibility for something like that. I don't know. I haven't done it yet. So just to show that out there, there's a couple different things. And of course we can predict. So I can't predict if I just give you 1x. I'd have to give you the value for each predictor, right? And then you could plug them in to the equation. And you could do that with a calculator. You don't have to have Minitab for that. I mean, you can use Minitab, but you don't have to have it. All right, and then of course the interpretations of the coefficients and that sort of thing. Number 11 is a chi-square test for homogeneity. We've already kind of talked about that, and remember, and right there you can see, it says of 3 types. So I have 3 different samples right off the bat. And then it says 3 types, but if you see something, I like to say, like I took 3 samples. then you know it's multiple samples. I just like to be clear because I don't really like to trick you guys on that stuff. Any questions on any of that stuff so far? No? Okay. I'm just trying to do like a quick overview, you know, just maybe spark some questions or just remind you guys of some stuff. Number 12 should be simple after we've already done the multiple linear regression problem in number 10. So this is an SLR, simple linear regression. It means I have 1x, 1y. So this one should be pretty quick, although I ask like a lot of kind of questions in this one. And I think the key here is like I'm looking to predict, right? I talk about X and Y, and I'm looking to predict something. That's how you know you're in regression. And then I've got one-way ANOVA, number 13, with a block variable, and it says that with item as a block variable. This is the problem we did in our lecture. I just was tired and I could not come up with a new problem, to be honest. So I just took one that we've already done. But it is a good problem. I like it because it's very clear. I feel like it's understandable. It's relatable. Like I feel like most of us have done this. You know, and we see the signs at Wegmans or Tops, and they say they compare the prices and that kind of thing. So that problem, I think it's pretty straightforward. And I tell you, it's a block variable. Item is not a second factor. It could be if I wanted it to be, if I asked you to do that, but that's not what I'm asking. I asked it to be a block variable, which makes sense in this problem. Okay, and again with the 2 keys on that one. Any questions on any of those? So I just quickly went through how to identify those. Any questions on any of those things? Do you guys have any other questions? Anything you want me to address? Like, did you guys look at the flow chart? The flow chart obviously is not this semester's flow chart because I was not at school to write it. And I do not have a big whiteboard like this at home. It is from last semester, which I'm glad I had. So it gives us a really good idea of, you know, how to break this down. If you want, you can write this kind of thing on your cheat sheet. A lot of people, this does help identify like what to do and where to go. Again, I will be providing mini tabs, so I feel like that helps you out as well. But you could see, like, if you have one sample, you either have one variable or 2 variables, right? And if you have one variable, how many levels do you have? Because that matters. So remember, the levels is if it's a yes or no question, or maybe it's like, okay, I use this in class all the time, so it's just simple. But like, do you have blue eyes? It's a yes or no, right? Or the multiple levels could be, what color eyes do you have? And then your answers could be blue, brown, green, hazel, right? That kind of thing. So that's what we're talking about when we say levels. It's how you can answer your question. Does it just break into 2 parts, or is it multiple parts? So you can break it, you know, how you can answer the question. Okay. You could have 2 samples of categorical data, and then you only have 1 variable. Multiple samples, you have 1 variable. You're studying the same thing. So the only time you have 2 variables is if you're doing association, which we went over that one. When you're looking at the numerical data side, on the right side of the flow chart, we're always studying 1 variable with numerical data. So we're always studying that same thing, the average of the same thing, same numerical. But here, it just depends on how many samples I have. Do I have 1 sample, 2 samples, and multiple samples? If we have multiple samples, we know it's going to be an ANOVA. It's just we have to decide, okay, how many factors do we have? And is one of the factors a block? That kind of thing. With the 2 samples, I have to decide if it's the pair T or the 2 sample T, so meaning independent. And then the 1 sample is what we're used to doing. And then I also have that little flow chart for regression. I'm just pulling them up as I'm talking about them to see what I have here. And then the regression, you can see the multiple linear regression, a lot of it, I just point an arrow over. It's the same, it's the same, it's the same, because a lot of it's the same. When I'm doing my test, it changes for my beta, because I don't have just one beta anymore. I have one for each X, each predictor. So that one changes. And then for if we think it's practically useful, so would we actually use the regression to, like, would we feel comfortable using it to make a prediction? That's R squared adjusted for MLR and just R squared for SLR. Okay. So that's those two things. We are allowed to use a cheat sheet on this final exam. We will be able to use a two-sided 8.5 by 11 cheat sheet. It can be handwritten or it can be typed. And then I will ask you, just like I did on exam 2, to upload that to a separate Dropbox. And then that way we just have that documentation. So you are able to do that. It's not required. It's if you want to. It's a nice way to study and kind of organize all your different tests and data. But just keep in mind, this will be more like exam 2, where I'm not going to ask for a ton of write-ups, I don't believe. Again, I didn't make it yet, but I'm going to try to do more about follow-up questions on this stuff. Any questions for me? Anyone want me to look at any other things? Any other questions, like any of the multiple choice or anything? I don't know if you guys have tried. Is the multiple choice open? First of all, I thought I opened it, but I try to do these things, and sometimes I'm doing them late at night, and then it is open. Okay, it's like I think I do it, and then sometimes my computer dies. So I have the review out there. I don't know if you can see your answer, or, you know, like when you answer the question on there, if it lets you review it. It's so hard because I can't see what you guys see. I can to an extent, but on something like this, I don't know. Like, I don't know if you can review it. So if you try that and you can't go back and review what you answered and see why you answered something wrong, or, you know, the correct answer, then send me an email and I will try to fix that. Sometimes it works and sometimes it doesn't. I think on the graded stuff, it gives me a hard time about doing it. So like when it goes into the grade book, which obviously the exam review would not. So we can try that. When I post your grades, I will post them separately, meaning the multiple choice will be posted separate from the part 2 of the exam for the final. So you can see exactly what you got on the multiple choice section compared to the other section in the final exam. Trying to think if there was any other things that, like, I see a lot of problems with, or that we tend to forget. I feel like we're just really good at writing hypothesis tests now. Like, we've been doing them and we notice that they're all like the same all the time. No other questions? No one wants me to do anything? I mean, the multiple choice will say things like, how many degrees of freedom do you have for this type of test? Or it might give you a scenario and say, identify this type of test. So they're all things that you need to know for part 2, right? It's nothing that you wouldn't usually do when I do the multiple choice. It's just, I want to know, like, if you're not looking at Minitab output, can you tell me what it is just from the problem? That kind of thing. You know, it kind of takes it like that little bit, like that step further, right? So, you know, like maybe what kind of requirements would you check for this type of problem, that kind of stuff, right? So I don't know if there was anything weird on here. We do have a TA review today too. I should post that. I don't know if I have that posted. I mean, I posted about the review, but I don't know if I have the reviews. So Jake, from my first section of Stat 2, like my Monday, Wednesday class, he will be running a review today. I have the announcements. I believe it's at 12:30, and he's going to run that until 2. So he'll go through that multiple choice. I can post that multiple choice because I don't see where I put that up. So it's just an additional thing. So if you have questions on that, of course. Do you guys have any questions for me? Anything anyone wants to know? I tried to spell everything out on here. No questions? I'm trying to see if there's something else. I try to, oh, Nathan, I see your email here. Sorry, I was late on posting the link. I realized I didn't post it the other day like I did for the other things. Sorry about that. I'm just gonna skim really quick to see. But if you guys have any questions, feel free to ask. I'm just gonna skim this multiple choice to see if anything pops up. Because there's a lot of things, like I'll say, oh, someone asks this a lot. Like I get a lot of questions about something specific. Oh, question number 3. I don't know, these might be mixed on your end. But on the review for multiple choice, it says, which the following value will always be within the upper and lower limits of a confidence interval? This is like a question I would even ask my Stat 1 students, and it's like people always ask because they just forget. Remember how a CI is built? A CI is built around my best estimate, my point estimate, and my point estimate is going to be that sample proportion or that sample mean. So in this one, it's the sample proportion. Remember the population proportion, it will only be in there like 90 out of 100 times if it's a 90% CI, right? So that one, it's kind of tricky, but it's not really supposed to be tricky. You're supposed to just think about how it's calculated, and it should be simple, but for some reason, it gets tricky. I think we just kind of forget. Although I do write my point estimate plus or minus margin of error every time we do a CI, even though you guys already know it. Let's see, just another one, picking it out. Okay, so like I said, the order might be different, but question number 5, it says the normality test, and I have my p-value, and I want to know what is the decision. Remember, if I'm doing normality, I want that p-value to be greater than 0.05 to show normality. It's like we know it, but I think if we read something like that, we get nervous, we get confused, especially when we see the multiple choice answers there. My suggestion is, and this, I know you guys hear this all the time, try to answer the question before you look at the answers, and then pick out the answer that matches the way you would answer it. But I know it's easier to say that than do it. Trust me, I've been in your shoes. So degrees of freedom. So like I was mentioning. Okay, again, the sample size. So just like I mentioned, a lot of the same things that I just talked about. I don't see a lot of tricky things. I'm just skimming through this really quick to see if I see anything.
It says all the Minitab will be provided. Does that include like the beginning half of the semester as well with the chi-square?
Yes, because I have some students that they don't have access to Minitab. So that's why I started providing the Minitab. I really want you guys, that's why I'll say, like, on the daily, please still do the Minitab if you can, but I still provide it in a separate document. And on the exam, I have to provide it so everyone's on the same page. Yeah, it's kind of a bummer to me because I think the Minitab is a big part of it. And I think I give a lot away. You could look at the mini tab and you can get the answer. Like you can tell what kind of test it is if you're familiar with it. But yeah, so I will be providing mini tabs for every problem.
All right, thank you.
Yeah, you're welcome. Let's see, like checking the requirements. That's what I was saying. Like the multiple choice, I mean, it's really not different from what we've had. It's just new topics, but the same kind of thing. Like, what is the first test for a two-way ANOVA, right? It's my interaction test. You know, what type of test is this, and how many degrees of freedom? I don't really see like a ton of differences. The TA review that's out there, there's like a big chunk of review on the regression stuff, and then it's kind of mixed, but it's geared a lot towards the regression since that's the new material. So I think that's a good one. Again, you can't make it to a TA review session. There was one yesterday and there's one today. I don't know if the third one will be offered or not, but I will post those with the solutions anyways, so you guys have that. Yeah, all these multiple choice, it's really going through a lot of the same things that like I've already mentioned. I don't see a lot of, you know, different type questions. I was just skimming through this. This is like a nice review on here. It's like I feel surprised. I forget because I generally use, like for the final exam review, the same review because I cover the same topics every semester, maybe a different order. But then I kind of forget what's on here. Yeah, I feel like this is a really good review. And nothing really crazy, just a lot of picking out the test, maybe your null and alternative. That's always a good one. Remember, if you're in the middle of the, wow, this is a really long review, which I really like. I feel like that's really good because it gives someone a lot of options if they really want to look through a lot of this. So remember, if you get that screen, this happens sometimes in person. So I don't know, no one has said anything that it's happened from home. But if you're in the middle of the test on the multiple choice section and a screen pops up and says that you can't go forward or backwards, or it says something like, are you sure you want to move forward? But then you can't do anything. You click OK, nothing happens. You can't X out of it. All you have to do is refresh your screen. It will not delete your exam. It won't send you back to the beginning. It will just refresh that page. It was kind of scary when that happened in class. I didn't know what to do for some students, and we had the tech guy up, and he said, try to refresh it, and it worked. We didn't know what was going to happen, but so that's how to fix that. Yeah, I feel like this review, the multiple choice review has a lot, and like I said, the TA review has a lot of the regression stuff on it. Are there any, oh, sorry, I see that. So it's not that it's going to be more focused on the later half. It's just, you know, so question was, is the exam going to be more focused on the later half of the semester? It's not. It's just that you know regression will be there because we haven't had that in an exam. So you know that's going to be there, so you know you need to understand regression, right? I know there's a lot of different parts of regression. I mean, but really there's two parts. Simple, which is old news, but with some new stuff, right? Because we did that in step one, and then multiple linear regression. But there's a lot of different parts to it. But I feel like we took it nice and slow. It built, you know, one day would build off the other day nicely. So, but we know it will be on the exam, so make sure we can do that. And then the rest of the exam will be mixed with categorical, numerical, and that kind of thing. Yeah. Are there any other questions for me at this moment? Let's see. You are in my Monday, Wednesday, right? Oh, Tuesday, Thursday, the 10, or wait, are you in the 10 a.m. class? Oh my gosh, sorry. I got that wrong completely. I'm so sorry. It's like I lose touch of which class we're in. Let me see. So that class was behind, I believe. So you're section 5. Let me see. So you guys were at 83% last night. I know it has been a while, and it's like when I see everyone's face, I'm like, oh yeah, I know, I can remember exactly what section you're in, and then all of a sudden we're out for 6 weeks and I don't. Let me take a look really quick. and I can give you guys an update. And now they ended last night, so we can't do anything else about it. That's why I sent the emails out about the evaluations to see where we're at. I gotta log in because it sends me an email like every few days, but it never gives me like an end result. Let's see here. So actually, yes, section 5 got 91%. Section 2 got 94%. And section 8 got 88%. 88%. And my other class, my stat 1, got 95%. So it's awesome. Yeah, great. I love that. I love it. I love reading. I should say I love reading the feedback, and it is hard to hear when someone doesn't like something, but I do. I really take it. I really look at it and see what I can improve. So I really do appreciate you guys filling those out. So that's awesome. Good. Oh yeah, yeah. Oh, you did send out a mass. I had someone else in one of my other classes send out a mass email too, like my Stat 1 class. Yeah. Awesome. Well, thank you for doing that. I appreciate that. Any other questions today? So I want you guys to remember that you can email me. I'm still available, even though I'm not going to have online chats. If you want to meet online and do an online chat so we can share screens and look at things together, I'm willing to do that. Just let me know. Just send me an email and we'll set up a time. That's fine for me. So, we'll work out whatever we can. If I get a lot of people asking for a second review, I will do that, but I don't know if I'll get that because this is recorded and anyone can watch this. But if you have questions on something individually, feel free to email me and we can do anything like that. All right. Well, I hope you guys have a good day. It's a little bit warmer here in Rochester. It's supposed to be almost 60 today, so I'm looking forward to that. I hope you guys have a little bit nicer weather too. So I was tired of the 40s and rain and snow last week. So, all right. Well, I hope you guys have a good day. Thank you for joining me today. And let me know if you have any questions. All right. Bye.